I want to thank you, Örjan. I think that was a very important and inspirational presentation. So I believe we all recognize that climate change is a grave challenge of our time. It's a grand challenge for science. The multifaceted anthropogenic perturbations on nature from our human activities is a complex system. There are scientific uncertainties, I'm going to touch on a few of those. It's also a grand challenge to society and stewardship of our entire civilization. Our generation is in the driver's seat, not only as the cause, but also with opportunities for a cure. Science takes center stage in this. Both it helps us to understand what we're doing, the complexity of climate change, and also by means to test the effectiveness of various proposed mitigation and adaptation strategies now. But science and techno-fixes are not enough to bend the curves of climate change. We need transformations of all sectors of society, behavioral changes, the way we view ourselves and our interactions with nature. And we also need that on all scales, from individuals to business, to government, and to the global commons. We are now over 8 billion human beings on our dear planet. We, in the top 1 billion most affluent, have caused more than 50% of the climate destruction. We have a special responsibility. The bottom 3 billion, with the least resources, they have caused 5 to 10% of the climate pollution. Yet they suffer the climate crisis and evolving climate catastrophe the worst. There are serious issues here of intergenerational and intragenerational climate justice. There is hope. This is in our hands, and there is a lot of transformation going on. Unfortunately, it's going way too slow. That train of transformation goes at 20 kilometers per hour. Because of our late start, we really need to speed at 140 kilometers per hour right now. As we see in that plot by IPCC, there are many different trajectories we can follow. Some of the lowest, most optimistic curves, they might scientifically not be feasible any longer. But it's very important that we stay at the lower trajectory of those in the picture there for at least a semi-sustainable stewardship. I also would like to mention the Planetary Protocol for Climate Change Resilience. It was established as part of the summit here in May, from climate crisis to climate resilience. Also happy to share that this week at the United Nations Climate Week in New York, it is also being discussed. But to establish some common grounding, there's a complex soup of human emissions of gases and particles, aerosols, that cause disruption to the Earth's radiative heat balance and cause climate warming. Carbon dioxide is the most important, especially in the long run, but I'm going to touch on two others. Methane is a very important short-lived climate pollutant that stands for about a third of the climate warming right now, with much larger scientific uncertainties, both with respect to sources and sinks. And there are signs, worrisome signs, that the climate warming now is triggering warming-enhanced releases from natural systems, such as tropical wetlands and permafrost. Also, I'll talk a little bit about aerosols. Sulfate, nitrate, and carbonaceous aerosols that scatter radiation back to space. That means that they're cooling the climate, this anthropogenic perturbation. That has the implication of the fact that we're not yet experiencing the warming that we deserve from the greenhouse gases that we have released. But there are large uncertainties in aerosol sources, properties, and processes. And as Professor Persson will soon tell us, I hope, we still need to remove these aerosol climate coolers because they have very large effect on public health. So there are many initiatives, and IPCC is a great report, but you know, it only counts every 6 years. And IPCC was never designed to provide the policy-relevant climate science that the policy process requires. In that void, many others are stepping in, such as the Global Sustainability Research Program, Future Earth, the Earth League, World Climate Research Program, that in recent years has put together this important product 10 new insights in climate science of policy relevance. It is presented at a high level at the annual COP meetings. And I'm highlighting 3 that I'm going to touch on today. One is the fact that science shows that overshooting the climate target that we promise future generations is becoming inevitable. What's the consequence of that? The second one is that we are decreasing aerosol air pollution now. That means we're demasking these climate coolers. What's the consequence of that? And the third one is that we're finding that the methane levels in the atmosphere is increasing in an accelerating rate now, where we really need to go in the other direction. What's the reason behind that, and what can we do? So there are many climate curves to bend. We saw the great acceleration curves by Jürgen Wren earlier. So there's a climate curve for everyone to bend. We can all be part of this. Atmospheric CO2 has not been this high for over 2 million years. The top left column shows CO2 measured in ice cores over the ice ages. So you see 180 parts per million CO2 during an ice age, going up to about 280 parts per million during a warm epoch like the present one, waxing and waning back and forth until recently where we're out of bounds. It's much, much higher. And the top right one, we see the real measurements in the background atmosphere of the keelings. And already back in 1958, it was already at the very high 315 ppm. But 60 years later only, it's 415 ppm. That's 100 ppm greater in 60 years. That's the full amplitude between an ice age and a warm epoch. To put that in perspective. The bottom right is a climate curve we really need to bend, and we can. This is the carbon dioxide emissions from fossil fuel combustion and land use change. Unfortunately, we're not still bending it. It's still hovering at 40 billion tons CO2 per year, and we can't stay at that for many more years until we really pass critical climate thresholds. But what about if we overshoot the climate? And maybe we can only do it temporarily. Does it matter then? Well, you look at the bottom curve, it's about emissions, and you see the curve there. If we still keep going up, but then we peak, and then we, through the rest of the century, are able to decrease emissions and bring us down to net zero emissions. What happens to the temperature meanwhile? Well, it stays high, and it's affecting the Earth system. And it can have, irreversible effects, and we're going to talk a little bit about that. And then to bring the temperature curve down, we need to have net negative emissions if we wait further. And those are extremely difficult, extremely challenging, and we have to have them every year for a long time. And there are no techniques that have been shown to function at any scale of that. So there are large questions of achievability. So we enter unknown territory of Earth system functionality and consequences for humanity. Large risks. We might pass thresholds in the Earth system functioning with climate overshoot. Some examples is that if 20 or 30% of the Amazons disappear, the rest might go by itself. If the Greenland glaciers start melting and coming down at the top to warmer layers in the atmosphere, it's going to be unstoppable melting for the rest of the Greenland glacier. There's self-enhancing release of methane from tropical wetlands and thawing permafrost. We should minimize climate overshoot. Aerosol masking. So this is a forcing diagram in watts of heating per square meter anthropogenic. It's a little bit complex, but you may see the purple line on top is that one from CO2 only. It's kind of strange that that one is above for a long time the thick black line, which is total forcing, which is less than just that from CO2. The reason is the line that is underneath the zero. That's the climate cooling line from aerosols. But you see what has happened recently is that's flattened out and now goes upwards. There is less cooling from aerosols. That means that the black line is now above the CO2. So that's why the reason why we integrate over some years, we're still observing a warming of plus 1.1 degree, whereas we really should be expecting just from the greenhouse gases 1.9. But there are very large uncertainties with the effects of aerosols. It's complex science of this masking effect due to aerosol-cloud interactions, the composition of aerosols matters, and the climate sensitivity. I'll share with you a dream for a climate scientist. That is that we will be allowed to do an Earth-wide geophysical experiment to really measure and constrain this important phenomenon. So all it takes is that we stop with air pollution for just 2 weeks. We couldn't agree on Earth, just stop air pollution for 2 weeks, we could constrain this very important factor. We got that through the COVID-19 induced societal shutdown. So that's that large geophysical perturbation experiment of the atmosphere and climate, illustrated by the photos here from central New Delhi. To the left is the way it normally looks, and to the right is during the COVID shutdown with cleaner air, bluer skies, and so on. And we were ready to measure the effects on the climate. We used our atmospheric receptor observatories located on the Maldives to catch the outflow from South Asia and in the rural southern Bangladesh to catch the outflow from highly polluted Indo-Gangetic Plain. Been operational for 20 years. The Maldives one started by Paul Crutzen and Ramanathan and others. And we combined that with satellites and modeling. And we found that the decreasing aerosol loads was actually there over a very large scale. And it led to bluer skies and cleaner air, but unfortunately it also led to warming, and we could constrain how much warming that caused. So we're now starting to have a constraint on that. The implication long term is that as we defossilize our economy, we decrease air pollution, we are going to, in a transition phase of several decades, have climate warming. It's a bit counterintuitive, and that's going to be a communication challenge. But we have to go through that phase. Switching to methane. Methane has, relatively speaking, increased more than CO2 in the atmosphere. And in recent times, it is accelerating the increase to the level of mixing of methane in the atmosphere now that is no longer consistent with even the 2-degree target of the Paris Treaty. We're above that already now. Why is that happening? Well, the blue curve is the same thing. It's the average methane mole fraction in the atmosphere. The red one, and then to the right one here, is the stable carbon isotope composition of atmospheric methane. Think about it as a source diagnostic signal where the methane is coming from. And if you see in the right one, it has been increasing through the Anthropocene until very recently, where it all of a sudden stopped and started going down. So that's diagnostic of a major paradigm shift in the global methane cycle. So it points to the fact, this change in trend, that there are larger changes now in increase in biogenic sources than in fossil sources. Biogenic sources can be anthropogenic, such as from rice paddies, wastewater, and ruminants, but also from natural. They will stimulate increased releases from tropical wetlands and thawing permafrost. I'm going to share a little bit about Arctic permafrost and methane releases in the context of the Paris Treaty. The Arctic permafrost holds an enormous amount of carbon, more carbon than in the biosphere on land. A lot of carbon in the top 1 to 2 meters, and it's thawing, and the warming in the Arctic is amplified. It's much more warming up there. And the right one, we're estimating, as permafrost scientists, how much additional methane would be released from land permafrost in green if we have a 1.5 or 2 degree warming consistent with the Paris Treaty. And then there's an additional unknown methane from subsea permafrost and collapsing hydrates. So you see that if we have 1.5 and 2 degrees, we're going to have climate overshoot due to this natural enhancement. It's a climate feedback with the Earth system. Some Mother Earth sort of responds to that warming up in the Arctic. So put that in context, if we reach 2-degree warming, the greenhouse gases released from thawing land permafrost this century will be of the same scale as emissions from the entire European Union. But there is a lot of good things happening. Talk about methane. The Global Methane Pledge is a fantastic initiative, pioneered by EU President Ursula von der Leyen and US President Biden, but with many, many joining. The idea is to cut global methane by 30% from 2020 to 2030. That would shave off as much as 0.3 degree warming by 2050. That's a major, major deal. And we need everyone to be on board with that. And mitigating methane is cost effective. There is direct economy for those that do it, because methane has a value, natural gas, as co-benefits with human health and agriculture. So to bending the curves, there is a lot of good things happening right now. There are many recipes, I call them. ways we can transform, including nature-based solutions for certain, but it's going way too slow. The World Meteorological Organization says the pace globally at current is a factor of 7 too slow. So we really have to accelerate this process. So bending the climate change curves requires integration of knowledge across all sectors and collaboration in new alliances. We definitely need technological innovations, including AI, new market mechanisms. But I think in the center here is also a very important aspect. We need a change in behavior and how we value our interactions with nature on an individual, but also on the organizations that we are creating. How they're happening. And I think these societal transformations and behavioral changes is an important ingredient for making this happen. And here I think the academies here and other organizations can play a very important role in its capacity of convening people from different sectors towards action. Scientists, faith leaders, and decision makers, and others. And that's what happened repeatedly here. One is with this Planetary Protocol for Climate Change Resilience. As Ram mentioned, its central pillar, 3 pillars for the musts, is mitigation, adaptation, and societal transformation. A strategy to survive and thrive the climate crisis. But how are we going to make it happen? Well, I think there's a very smart strategy of the key organizers behind that, to focus on inviting many people, but especially on sub-national government leaders. They're empowered to make decisions. And there were many of them coming from all over the world. I'm illustrating 3 of them signing the protocol here. They were here with their delegations. And they pledged to be the flag carriers in operationalizing and implementing the Planetary Protocol on their own scales, and showing by their ways others. And naturally, I'm also very appreciative of the church. In addition to facilitating this through its convening power, also disseminating the protocol message in its own words to its many followers. So I talked briefly on climate overshoot, on aerosol demasking. Yes, methane mitigation is a low-hanging fruit. We have to do it now, and we have to do it to provide a climate-resilient world for our children and grandchildren. Thank you very much.